You'll see it pop up in a second that we're live. We are good to
There's
go.
Park. Yeah, there's Park.
Hey there.
All right, so we're ready to go.
Yep, everything's all good.
So I'll just change my slide and we'll be going. We already are. All right. Welcome to the American Institute of Steel Construction's 2025 Forge Prize final jury. The Forge Prize since 2018 has been a really unique opportunity for architects to experiment with conceptual design related to structural steel. And without limit to scope or complexity, really sky's the limit. The competition celebrates emerging architects, architecture faculty, and graduate students in architecture who create visionary designs that embrace steel innovations. The jurors have narrowed the field down to 3 finalists who have already won $5,000 each and have spent the last couple of months working with a partner steel fabricator to refine their designs. They're revealing and presenting their refined designs today, and the jurors will deliberate on this call and return to announce a grand prize winner who will win $10,000. So the AISC, American Institute of Steel Construction co-hosts, are Nima Balasubramanian, director of AISC's newly formed Architecture Center, and I am Jean Homer, AISC's architecture manager in university relations. And we welcome 3 jurors this year. We have Emily Baker, an associate professor at the University of Arkansas, who was also the 2024 Forge Prize Grand Prize winner. So we're so happy to have her. We have Park McDowell, an associate principal and director of fabrication at Payet. And then we have Matthew Marani, a special editions editor, special sections editor at Architectural Record. And we're so happy to have you 3 here sharing your expertise and supporting the Forge Prize. I'd also like to thank the member fabricators for mentoring, sharing their expertise with our finalists over the last couple of months. We have Tony Buffone of MSI Fab in LLC in Newark, Delaware. We have Ralph Barone of Barone Steel in Brooklyn, New York. And we have Schlosser Steel with Phil Schlosser and Barry Gossler in Hatfield, Pennsylvania. And finally, we have our finalists this year. We have Ahmed Ali from Texas A&M University, located in College Station, Texas. We have Ho-gyum Kim of CZS in New York. And we have Kaikang Shen of K2SA in Los Angeles. So we're going to go ahead and begin our presentations, and we will start with Ahmed Ali. I will. So you can share. There we go.
Well, thank you, Jean. Thank you, AISC, for this opportunity to present our project to you today. It's an honor to be already in the finalist of this group. My name is Ahmed Ali. I'm Associate Professor of Architecture at Texas A&M University, and I'm presenting to you today a project about transforming galvanized sheet metal waste streams from the auto industry into the modular living wall planter system. This slide shows some of the highlights of the benefit of the system that we have designed, built, tested, and created at Texas A&M University. First and foremost is the idea of activating the circular economy through the industrial symbiosis between the building industry and also the automotive industry. And we do this through the repurposing of steel rather than recycling it, and I'll talk more about this. We also have the aesthetic benefit from this system because it is pleasantly appealing even the plants are not thriving when the plants are not thriving due to the seasonal changes. It also has the easy management benefit because each unit is individually can be easily removed. It improved the microclimate both outside and also the heat gain on buildings. And we've measured that it's between 10 to 12 degrees, reducing heat gain on building as well. It's a home of inviting natural habitat to urban areas. So we see that this innovation would be very beneficial in dense urban cities. And lastly, overcoming the challenges of existing building and retrofitting as well. I think all of us cannot argue the fact that steel or structural steel is the most sustainable choice. And almost 93% of steel that we produce today is a recycled content, and it's 100% recyclable. But we also see publications from AISC back in 2017 talking about the more than recycled content in the steel itself, and particularly about the ideas of reuse of structural steel, and also the waste that comes from castellated beam fabrication, for example. This idea about reuse of material in general and steel in particular is also gaining interest recently. So we've started to see in publications that promote and trying to measure the challenges and opportunity of reusing structural steel. Of course, as you know, the biggest problem to this is the unpredictable sizes and shapes and other properties of the steel itself. But if we turn our head to the auto industry, and every one of us drive a car or truck or other vehicles, we see the consistency of the waste flow is now predictable. It's a high volume, and we can design from it. So General Motors, for example, when we ask them to provide us with their offal, and an offal is a term that comes as a dropout of creating the doors and panels of the car manufacturing. They give us 11 different offals, as you can see from the table below, with thicknesses, with the volume that they produce from a certain plant per month, with what type of zinc coating, thicknesses, dimensions, everything. So we take this irregular, already corrosion-resistant shape, and then we immediately start to design with it building systems. The two photos at the bottom shows a roofing shingle system made of these galvanized sheet metal, and one on the right is a faceted paneling system that use 100% of the waste. So we don't want to cut even more of the already existed waste flow. We just want to use 100% of it. When the opportunity on the Texas A&M University and Central Texas presented that we have this south wall on the architectural building that has been closed like this for several years, we started to think about vertical greening and how can we add or create a system, as you can see, that's composed of planters that's becoming also a building facade, a metal building facade, including irrigation system and all things needed for a vertical greening system. And hopefully this system will become a background where the plants mature, it covers the entire thing. So these are the initial renderings of the project. And the idea of the module comes as a very simple exercise of drawing a circle and intersecting it with the same diameter of other circles. As you can see in sacred geometry, basic practices, this allows for this diamond-shaped unit to also have the high point where it protects the soil from splashing and also hide the irrigation hole from the back. And as you can see, the system is expandable, so it scales up to any condition or any situation. So we went back to the General Motors 11 different kinds of offals, and all of them comes from different vehicles that we ride, and then we tried to maximize the sheet metal that we use. We ended up making it out of two pieces, one in the front, one in the back. We cut them on a water jet, and then we assembled them with aluminum rivets as well. As you can see, we tried to fold the unit from one piece, but it was difficult for manufacturing reasons, so we ended up doing it from two. This is some images of the final result. The system is, as you can see, even without the planting thriving, it acts as a metal building facade. The supporting structure for the units were thought to be out of conventional structural steel, HSS hollow tubes that's making the frame. We thought of this boomerang shape supporting structure, but we ended up, doing the triangle that you can see on the image on the right side, but all made of, regular steel. After we were selected as finalists, we went back to the drawing board, and with the help of our collaborator and fabricator, Nate Kilpatrick from Bastin Steel, Texas, Tony Buffoon from Delaware MSI Fab LLC, and William Dinesco from our TAMO Fab Lab in Texas. We went back to the original geometry of the system and started folding it, trying to also use the wasted plates of steel as the supporting system. As you can see, this is the first mock-up that we made on the right, where we also water jet this reject steel from pieces that's rejected from manufacturing, and then simply folding it, creating an additional screen behind the system, as you can see. And it's providing the self-supporting system for the units as well. So again, going back to not wasting any more steel and using what's available or reusing what's available there. Of course, there is more development about the geometry and how the lines join together. As you can see on the image of the left side, where we need to go back and trying to introduce more stiffness to the joints as well. We couldn't have done this without collaborating with our fabricators, as you can see in the image, and inviting industry partners as well. The image on the left is just one of hundreds of posts on social media, where it shows how beautiful this wall is, as well as how functioning is it in reducing heat gain on building and helping with the microclimate. And last but not least, we couldn't do it without our students, that they plant and cut and help us doing the work at A&M. Finally, I want to share with you a 90 seconds video that's summarize our project.
Imagine a world where waste from one industry fuels another. What if byproducts from automotive manufacturing became building facades? The global automotive industry generates consistent waste streams of galvanized sheet metal during stamping operations. This metal, which costs 50 cents per pound, is sold as scrap for just 6 cents per pound. By transforming automotive waste into building facade panels and living wall systems, the industry can sell this waste for more than scrap value while providing a cheaper alternative to raw materials. I'm Ahmed Ali, and I'm dedicated to activating the circular economy through industrial symbiosis. Our patented modular living wall planter system, made from automotive waste, thrived during Texas's record high temperatures in the summer of 2022. It outperformed ground-planted alternatives while reducing heat gain on buildings by 10 degrees Fahrenheit. Our system excels in both function and aesthetics, even when plants are out of season, something many vertical greening systems lack. Beyond its aesthetic and environmental benefits, it positively impacts urban heat islands and air quality. Let's transform waste streams into products and create a future of closed-loop collaboration between industries.
Thank you very much.
Thank you, Ahmed. So now we have jurors have a chance to ask questions for about 8 to 10 minutes. So whoever would like to start off.
Thanks, Ahmed. That was a lovely presentation, very clear. We appreciate, I think I can speak on behalf of all the jurors, incorporating some of our comments, such as exploring opportunities to use the same repurposed storytelling in the backup structure, as well as just the exposed facade elements of the planter system. So thanks for that exploration. Could you tell us more about two things? One, the next steps for this product, which is well resolved, and I see that it has market capabilities. And then the second question will be about your workflow with your collaborators on the industry side.
Absolutely. Thanks, Mark, for the very important question. As for the first one, next steps is, and I'm very happy that now presenting to the AISC community. As you can see, most of the ideas regarding reuse of waste streams or so are not scalable. But we, at our resource-based design research lab that we founded at A&M, we want to create scalable projects, and the fact that all the automotive industry around the world make the car body out of the same manufacturing processes, our hope is that system become scaled globally, meaning that all the auto manufacturers buy into this idea, where at the time of designing and making automotives or cars, the same side on the building industry and construction industry side are reusing this steel, and we already know that it's recyclable, but I think we can save also a lot of energy when we start to avoid degalvanization and smelting in making steel. So I'm not arguing that I'm replacing recycling of steel, but what I'm arguing is there is a considerable portion of most manufacturers around the world that we can work together and build and think differently about these. So next steps is I hope to get more buy-in from many manufacturers, and we work together in scaling up the projects. The idea, we patented with the U.S. Patent Office, and we are seeking vendors and collaborators to take this to the market and provide it as a system that you can buy or install on projects, existing one. And for the second question, Park, is about working with our fabricators, right? So actually, we work with two. We worked with Tony from Delaware, back and forth. We had many emails about, what else, what other waste flow from the structural steel that we can that we can use in the backing or the structural support of that system. And we thought about a lot of different approaches. But since that backing structure is completely hidden, I think we can even reuse some of the structural steel that's being decommissioned or dismantled or deconstructed from any steel building, and quickly build this supporting system. So we want to push that farther and try to identify a waste stream of structural steel that works and with our system, and kind of scale up that as well.
That's lovely. I've got one more comment actually to add before I relinquish the floor. Simply because you've done a lovely job capturing the economies of scale, and you've got a predictable stream of parts of a repeatable size. While I think water jet cutting is the appropriate tool for this kind of smaller scale investigation, obviously stamping is what you would do if you were to produce it at scale, and even potentially something that's embedded within the factory line floor. So it's stamped, there's your cutoffs specifically sized to your product, and then stamped, there's the actual shape they need. So that would be a manufacturing efficiency that I think this type of project is well suited to capture.
Absolutely.
All right. Yeah. Hi, Ollie. I just had a quick question about the prototype. So I guess in terms of scalability, I was wondering whether you see the prototype being applicable to unitized curtain walls within larger building systems, or if it's more, geared towards a storefront application going forward.
Excellent question. Thanks, Matt. We see our system almost like acting as a double envelope or a double skin of any existing building. You can incorporate that in the new construction, or you can add that secondary envelope to existing buildings. And if you just walk around any city, any downtown or any city, there is a huge amount of blank walls around there. Nobody asked how these walls are contributing to the urban heat island effect, either outside or the heat gain on buildings inside. And just imagine, the square footage of these blank walls around all of our cities, when all of a sudden now a double envelope like this can be installed and become a source of energy reduction, but also maybe a source of food production as well. And we've all seen this during COVID, where the shortage of, either, even vegetables and things like this was affecting all of us. So we see this becoming retrofitting as well as new construction in building as well.
Great, thanks.
Oh, yeah. Hi, yeah, again, thanks. I think it was a quite clear presentation, so you said a lot, but I was curious if you would say a little bit more about how water moves through this and how the irrigation portion is working.
Thanks, Emily. You said wire?
Water.
Water. Oh, okay.
How does the water move? And how is it getting there? Where is it going once it moves through the soil?
Excellent question, and thank you for this question as well. We all about reuse. So the initial ideas was to harvest water, either rainwater or condensation water from buildings, and route this in, filter it, and then irrigate it. The structural supporting system in the back provide also a place where all the irrigation line sits in. So we have both vertical lines and horizontal lines, and all of these lines provide each individual unit through that central hole with almost like a drip irrigation system that almost takes a Dixie cup this much every other week. It's connected to the building right now, and it's automating, it's automatically irrigated every other day on a, automatic irrigation system. But I think to push this farther, we want to reuse water as well, So if we think when we scale this up, we'll be able to harvest rainwater or or gray water or even condensation water, and run this through filtration system and also to the system itself. Maybe also we can add nutritions along with the water as well. All of these things are in the works.
Okay. Can I ask one more follow-up then? Obviously, if it rains hard, needs to be a way to drain. So that you don't waterlog the plants. So is it draining out and running down the face of the units below? Is there something specific happening with the way the water drains?
Absolutely. So the back of the unit has two sets of hole, one hole in the middle for irrigation and three
Okay.
holes at the bottom for drainage. And when it drained after rain or so, it cascade to all the units below it, so all the units
Okay.
gets it as well.
Okay, yeah. I mean, that makes a lot of sense. That's what I was hoping it was going to be, but it was hard for me to see that maybe in in the images of the piece. Okay, thanks.
Thank you.
Okay, thank you, Ahmed, and thank you, jurors, for your questions. I think we're ready to move on to our next finalist, Ho-gyum Kim. Will talk about his housing proposal in New York. So go ahead and share your screen, and whenever you're ready.
You see my screen?
Yes.
Yes, okay. Okay, I would like to start the presentation. Yeah, it will start with defining the context and problem, the solution, and how it's going to be implemented, the design specifics, and how the fabrication and enrichment ideas, preliminary ideas. And first of all, I would like to thank AISC for providing this opportunity to experiment with concept of steel, concept that embraces the potential of steel. The major supply modes of NYC housing can be roughly categorized as what you see here: ground-up condos, NYCHA interventions, and the office conversions. But simply looking into the pure area, the zoning lots, these could be applied. The absolute stock of R8 to 10 zoning lots, the NYCHA lots, and the C lots are lacking the absolute bulk in terms of remedying the housing shortage. So on the contrary, when we look at the R4, 5, 6 zoning lots, we can see a big mass of zoning lots which has been never touched upon. And compared to the other zoning lots combined, we can clearly see the big difference. And if we look closer in this specific case between the 3rd and 9th Street and 4th and 8th Avenue of Brooklyn, we can see a typical cluster of row houses blocks where each block is roughly around 700 by 200 feet. And with the rear yards occupying up to 40% as per the zoning site coverage. And when you read them as a collective entity, the size of the rear yards are something that is hard to be ignored. So some inspirations in developing the project, we have the Hota Kubo housing by Riken Yamamoto, where it's organized, where the dwellings are organized around the shared courtyards, and it's only accessible through the units and a community center. And the next is the Affordance House by Class Architecture, which tells us how a building should sit on a limited narrow lot, and with its serpentine form and selective placement of windows, and how it's balancing the light infusion. And then at the urban scale, we have the Linear City by Peter Eisenman and Michael Graves, an interwoven framework spanning between New Brunswick and Trenton, and which within that buildings, it implies the movement and circulation of the interlinked infrastructure. So with these inspirations in mind, a testbed block is selected between 5th, 6th Street and 5th and 6th Avenue, highlighted blue here. And originating from the community plan of New York in 1807, the typical row house were designed with a width optimized for ambient light penetration. The selected block is roughly, again, 200 by 700 feet, and the face of the rear facade is usually not less than 40 feet from the rear lot line, and this gives us around 90 feet of dimension to work with. And if we inherit the typical row house width of, I would say, 18 feet and rotated 9 degrees and aligned with the center line of the block, the row house, it only encroaches 9 feet from the lot line. So it has minimal impact in terms of light and air penetration to the existing row houses. And when it's replicated, the row houses could be elevated to have minimal impact on the ground and vertically misaligned with the windows with the existing dwellings for privacy. And if we look into the four corner lots, they are usually, or maybe always, it has a one-story tail to secure the distance from the adjoining lots to provide light and air. And hopefully they could be repurposed to provide an entryway to the rear yard dwellings. And with these simple interventions, we could imagine from the neglected rear yards, a bunch of vertical row houses growing out from the brownstones. So I think this proposal could be aligned with the recently approved City of Yes for Housing Opportunity slogan, a little more housing in every neighborhood. And we can see that where they propose for the lower density, this overlaps with the lots I've selected for the project, right? And if we go to the implementation, we need to devise a minimal touchdown strategy aligned with the center line of the block, which can keep the existing row houses as is with minimal impact in the rear yard. So a system of 3 predefined frames assembled with a built-up member of curved HSS and off-the-shelf steel members could be introduced. The first basic type should be containing the dwelling units, and with the extended beams, they are to contain the corridor, balconies, and planters. And then the second frame type enables a distinctive entryway experience to the dwellings, and this terminates the aggregation model with structural joint, and the 18-foot grid is respected, inheriting the typical row house width. And then the third frame accommodates the circulation and has the ability to be combined with the communal programs, and these frameworks could be deployed in multiple scales, either vertically or horizontally. And programmatically, we can allocate the level of privacy according to the frame types from private, semi-private to public. And with the aggregation of these frame types, we acquire a building module, which is composed of 4 frame type 1s, and then 1 frame type 2, and then 1 frame type 3. And when positioned within the center line of the rear yards, a maximum of 5 building modules of 108-foot width could fit within the block, and depending on the demanded density, other configurations could be viable. And with this approach, we can accomplish a zone of intervention of 18-foot, elevated from the ground level. And as a proof of concept, we can test a multitude of possible scenarios. When a higher density is allowed, the building modules could intervene without demolishing the row houses. The existing houses could be maybe adaptively reused as other programs, maybe retail. And since the frames only touch the ground at the center line of the block, the prefab frames can be erected with minimal impact to the existing row houses. And to accommodate an ADU accessible dwelling unit scenario, the built-up member is just simply flipped to occupy the ground at the rear yard. In this case, the upper floors can be exclusively accessed through the rear yard, through the existing row house lots, and maybe it could add more value to the property in itself, right? And when the block is subject to landmarks applications, the scale could be drastically mitigated to comply with the view cone of the surrounding viewpoints from the block. And now we can delve into the design specifics. The first portion will be the residential chunk highlighted in the perspective here, and which is made up of 4 duplex units stacked with 2 3-bedroom units and 1 2-bedroom and 1 1-bedroom loft units. So this is unit type A with an entrance at the lower level with bedrooms on the upper. And then the 2-bedroom unit enters at the upper level going down to the LDK space. And then the 1-bedroom loft unit. And then this is unit D, an about face image from unit A, which would have the views to the opposite side of the from unit A. So this is a glimpse of the living space with the clear story leading the flow of the continuous flow from the kitchen, dining, and living. And a tentative bedroom loft down if you go down to the ADU scenario. And the access corridors are separated by level and mirrored, eliminating the need to wrap around the whole frontage with corridors, right? The upper 2 unit A and B share an entrance foyer. Upon entering the unit, one goes up and then the other goes down. The same happens at the lower units, only on the other side. Hopefully, these corridors provide a stoop-like experience when intertwined with the communal spaces and leading up to the roof. And with this cutout, we can see, aside from the structural steel frames, economical materials such as perforated steel and ephes are selected. And the balconies balance out the daylight from the large clear story windows, and the precast hollow core slabs. They can secure a ceiling height of 10 foot 6 inches at this point. And the units could receive natural light from both surfaces, right? And next is the vertical community element. In a typical building module, the dwelling units will embed a vertical circulation, which is a strip that climbs up to the roof, intertwining with the corridors. In the bigger picture, it would be the highlighted part in blue here. And expressed in this section, this can provide a very porous small-scale neighborhood amenities as an extension of each dwelling unit, and also accessible not only to the block residents, but also to the greater neighborhood. And probably, maybe tentatively, these amenities could have a rentable system, maybe. And this image shows the intimate nature of these amenities. And this could also be a receptacle to embed sustainability features such as the rainwater harvesting, wind turbines, PV panels, and such. And going down to the ground level, we can see there's minimal disturbance to the row houses and also the rear yards. And when it's occupied with the ADU units, a sense of intimacy emerges within the courtyard. When we rise up to the dwelling level, we can see the corridors meandering through the vertical communal spaces. And when we reach those will lead us to the roof. And possibly a running track in the sky could be a destination for neighbors for a larger radius, helping the activation of the amenities. And jumping over to structural ideas, each building module, the 108-foot span, is isolated from the structural behavior of the adjoining or adjacent building modules. And the tie beams at the foundations react against the movement along the long direction of the building. And then we have the X bracings combined with the core walls. It'll help with the shear along the long direction. And then and you can see the built-up HSS curve members are appropriated throughout the building at the external stair, the roof structure support, and then the trellis. And this will maintain a consistent architectural language at the ground, middle, and top, and allowing the custom member to be mass-produced to secure the economy of scale, right? And looking into the load path diagram, the vertical loads are relatively straightforward, and when the lateral loads are applied, the configuration of the columns is susceptible to overturning moments at the ground. So we'd like to introduce tie-down cables to provide the uplift resistance against the overturning moment at the ground level. And a breakdown of the building elements and associated materialities, starting with the concrete pile cap foundations, the above ground framing, and the boards and stairs. The hollow core slabs capable of spanning to 22 feet, the exterior stairs and corridors, and facade infill made up of cold form steel, ephes, and corrugated perforated metal, and the HSS trellis and the PV embedded PTFE at the roof. And finally, the elevated walkway to access the dwellings. And we'll move on to the preliminary fabrication and erection ideas. So here's the kit of parts of the structural elements, mostly a combination of off-the-shelf products with the exception of the curved HHS columns. And shown here is the tentative configuration each member is to be transported to the site. And the curved column sizing is referenced from the multi-story residential prototype 4, a steel solution for 30-foot typical span and 8 floors where the heaviest column is a W12 by 87. And when we transfer it to the HSS and WF column selection guide, we get an HSS 12 by 10 by 5/8 thickness. So with that,
Jim, I'm sorry to interrupt. We just have one more minute for you for your presentation. Okay.
Sure. So with this straight member, we have 3 segments and 2 curved segments. And looking into the bending methods, the cold bending, it has limitations to the radius. So it eventually will have to go to the induction method where our radius of 5 foot is applicable. And hoping to infill the HS column with fiber reinforced concrete, which enhances the connection capacity, and that would be placed within the factory. And the configuration of the column is prone to the rotational movement at the base, and displacement is likely to emerge. So the introduction of tension rods and the welder plate would help in resisting that. And we have the girder column module, which is made up of the delta beam, a prefab slim slab structure with castellated beams. This is connected as a moment frame, and this is a moment connection, and the castellated beams are connected as shear connections. And when they're traveling onto site, they will be stacked with this configuration with a steel tab connection here, and then the beam would be connected. So these are the remaining kit of parts, and as the mode, they will be transported to the site. And with this idea in mind, this is the sequence of the erection. So now it's just more of a stacking by floors, very, very straightforward. And then the exterior elements along with the facade infill will come in later.
Okay,
Yeah.
thank you.
Thank you.
So we only have time for one question from the jurors. So who wants it?
I have a question. Well,
Yes.
Emily.
Yeah, I mean, I had a question and a comment. The first one, the comment is it seems very like it should be modular in the sense of or designed for disassembly maybe instead of just modular is the idea, because
Right.
though I think you're right on that our big issue right now is housing and the amount of people, but I've heard some future projections that suggest that we aren't going to have this type of problem forever. So in the next 200 years, maybe that coming back down and not being there anymore might be part of the consideration. But I was just really curious about so many things very well considered, but the one thing that I didn't kind of quite see you dealing with was the thermal bridging into the
Right.
units through the steel. So I was curious about that.
Yeah, so if I don't know, yeah, so basically we have the cold formed steel backup wall, and then we have the ephes layer. So basically the ephes layer would be in a line with the structure members, and then the cold formed steel will be behind the structural members. So that's
Okay.
yeah, and of course between the ephes, the steel member, and the ephes, there will be yes, a certain level of thermal bridging, but behind that, that insulation with the cold formed steel backup wall, it's gonna, yeah, that's the line of enclosure for the thermal. Yeah.
Okay, thanks.
Gene, is there time for one small question as well?
One small.
Okay. Yeah.
Yeah.
So I'm just curious, because New York City has, tons of zoning and FAR rules.
Right.
What would have to change, or what sort of reforms would have to be made to allow to permit?
Yeah. Well, yeah. So yes. Frankly, this project is not is at the borderline of the zoning lots. So basically, there is no code or regulation that defines whether a building could actually like sitting with a single foot on the borderline of the zoning of the lot. So that's the major thing we need to address or reform in terms if we want to make this a reality, I think. Yeah.
Thanks.
Okay, thank you. All right, we are ready for our third finalist, Kaikang Shen, and his proposal for a short span bridge.
Okay, can you guys see my screen?
Yes.
Hi, hello everyone. My name is Kaikang. So let me start my presentation. So my presentation is pretty short. Hold on. So this bridge at Echo Lake in Los Angeles. Does that work? Oh yeah. And currently the bridge is abandoned and closed. But the local city want to reopen the island in the middle of the lake to the public in the future here. So based on current condition, I propose 3 questions. Like the first one, like at the bottom, the bridge is too close to the lake and it's hard to let the boat pass through. And the second question is how to make the bridge reconnect both sides of the lake in the future and in the new way. And the third question is how to create landscape the bridge to encourage people to interact with the water in the future. So based on these 3 questions, I started my design. Actually, the design was inspired by Mobius ring. It creates 3-dimensional spatial structure with the infinite loops and different levels to create different activities, such as the middle part of the bridge is all of the people pass through quickly, and the upper part here create a resting area, and you can enjoy the beautiful lake view and the sunshine. And the lower part here create a platform to encourage the people play with the water at any time or in the summertime. Finally, the one continuous curved surface integrate 3 activities on different level into one object. So next one for the components on the bridge. So this is my concept. It's also my testing in design. So I try to eliminate the hierarchy between them and try to show different functions and uses with one language. So for instance, sometime here, most of the time, they can be a handrail along the bridge, but sometimes it can be sunshade here or canopy here above the bridge. And sometimes it can be the guardrail here to protect people from falling into the water. And the shape of the liquid also corresponds the form of the bridge. So you can see those components along the bridge from this rendering. And the big difference between this time and this version and the last version is I designed structure and details. From this slide, the main structure of this bridge is rigid frame with a double column here, and double beams here. And both ends of the bridge, there are a lot of the fixed points to connect with the concrete foundation. All of this is just for increasing stability of the bridge and resistance of vibration and buckling. And for the secondary, the structure is made of the many curved beam, like here, and metal plates. And these metal plates with a varied shape also follow the form of the bridge. Finally, the outside, the one big continuous curved surface is divided by the pieces, and it makes production possible. And these are the details, and show metal plate, H-shaped beams, the pipe bending beams, columns, and those components. And then there are three metalworking techniques can make this bridge reality. The first technique named laser cut, and this metal plate can be made by laser cut. And the second technique named pipe bending, and it can create curved pipe beams for the bridge. And the third one and the last technique named the multi-point sheet metal forming, and you can create any curved surface you want. And from those renderings, you can read the details, joints, seams, components on the bridge from those renderings. And on the last slide, I also printed the bridge out by 3D printer. Those are photos of physical model. Yeah, that's the last slide. That's all. That's my presentation. Thank you so much, everyone. I want to show this is my for the layouts. The first page, and the second one, third one, and the last
We're
one.
not see I think I just see the 3D printed models right now.
Yeah, same here.
Sorry, let me share my game. Oh, here we go. Oh, can you see my screen now? Yeah, so my for layouts for the final, the first page, the second one, the third one, and the last one. So this is not conventional bridge. So this is my concept, my testing design, and try to create a new form with a new language like that. Thank you.
Thank you, Kaikang. Do we have any questions from the jurors?
Looking for, oh, sorry, go for it, Park.
Jump in.
I was just curious. I couldn't find the label while it was on the screen. You're saying that the exterior cladding is also steel, and I'm wondering if that's acting structurally at all, or if that's simply a cladding?
Oh, yeah. So the main structure is made of the column and the beams, and the base for the structure is concrete foundation. And because this form is pretty complex, so the secondary structure is made of the many metal plate like that, and it can shape the basic form of the bridge. Yeah, that's the main structure. And the second one, under the main structure, there are the H-shaped beams, and there are also the metal stud and steel clip. And the function of the clip just adjusts the spacer between the structure and metal plate. The body of the bridge is brushed silver metal plate, and on the ground, I add one more layer. Is a rubberized surface to increase the friction. It's not smoothie or sleepy. Yeah. Thank you.
I like the development that we've seen in the structural logics of it, because this is a kind of project that comes from a specific, geometric premise, and the structure is in support of that big idea rather than the driver of the scheme. And so I think it was a challenge that you've executed convincingly to say, okay, here's the actual way we're going to make the structure work. And having the two-part language of the structural ribs and components on the inside, and then on the outside, either the skin or the tube-based railing is viable. And we've seen that on bridges like the Batman Bridge in Melbourne with John Wardle and Nada that had like a similar kind of idea. So it seems just it kind of passes the sniff test. I think it's viable. I'm curious about your collaboration with the fabricators. When you give them this geometry, can you walk us through a little bit of the back and forth? Because I suspect whenever you've got a project that is challenging geometrically, there's a kind of negotiation between which areas can be adjusted and tweaked for fabrication efficiencies and which are more central and kind of untouchable with respect to the design.
Oh, yes, this is really big challenger to the consultant. So after discussing with Barry he's my consultant, and he has a really huge question about my design. He said, sometimes I have no idea about this. I'm not sure about this. So under his suggestion, on the initial design, I just add one more the beam. But he said there's a lot of the challenge on the buckling and the vibration. So yes, like that. Yeah, exactly. So after his suggestion, I add double beams with the double columns. But I think there's still issues on the span between the two columns. If more wilder, I think the bridge more stability. So I think if that's the next phase, I still need to keep researching and calculating on that. So I also increased the density of the metal plate. So the entire structure looks like the fishbone. More density, I think, the more stable, like that. But I still need to do the more research on that. But he said this at least this is feasible now. It's a pretty complex. Thank you so much. It's a good question. Yeah.
Are there any more questions from the jurors? Okay, if you have questions of the jurors, feel free to do that. I'll give us another second if something comes to mind.
Okay, I'm good now. So just share those
Okay.
screen.
Yeah. Well, thank you so much. Okay, so what will happen next is that the jurors are going to move into a separate Zoom room and make their deliberations. And Nima will be speaking with you. I think, Kaikang, I think you have to unshare your screen, so Nima will be able to share hers. And Zach will get us into our rooms. Okay. See you soon.
Well, thank you, you three, for doing additional work, and from your initial submissions to what it is now has been great. Seeing how your projects have progressed has been really wonderful. So I have a couple of questions for all three of you. Three of you spoke a little bit about your interactions with the fabricators and how that helped refine your design. But I'm just curious, what was their first impression when you spoke to them and discussed your project? What was their first reaction? Anyone can go first. Ahmed.
Yeah, good question, Nima. I think the first reaction was that, I mean, they very much like these to see these kind of ideas because they don't see it every day in their practice. So sometimes fabricators just, get into the production cycle of buildings, and things might be all the same, look the same. It's maybe a different welding here or a different bolting over here, but for them to see sort of like fresh ideas that they don't see every day was very rewarding. So I worked with two, Tony from Delaware, and then also Nat from Boston Steel, which happens that he also has a connection with Texas A&M University, and he provided a sketch with ideas, and we want to work together even after this is finished to keep developing the work.
That's great. That's what we from AIC want to hear, that more architects are collaborating with fabricators and continuing such experimental projects. Pushes the boundaries of the material, definitely. What about you, Ho-gyum? What was your fabricator's first reaction when you showed this project?
Yeah, I mean, at first glance, of course, they had some hard time understanding how it's going to be erected at some point. But when looking closer and closer, it wasn't that complicated, to be frank, because it's just a combination of off-the-shelf materials, and the connection types are very common or typical connection types. Just the but the only feedback that needed some consultation was the curved HSS member, and I mean Ralph was kind of helpful in terms of providing the bending methodologies and giving me some insights in terms of what the limitations and what the radius could be, and also how to reinforce those columns when they touch the ground, because the configuration is not the typical type of column we encounter these days. So yeah, that's the impression we had between us. Yeah.
Thank you. Yeah. What about you, Kaikang?
Yeah, I'm big challenge between designer and conductor. I think there's a war between them. Like this bridge design, I create a pretty complex form, and the structural engineer gave me a lot of suggestion and add more columns or add more the beams between them. Maybe they will destroy the form. So for the architect or for the designer, always focus on the final form, right? So so I think the key point for this communication is as a designer, I have to find the balance. So how to meet the stability or the safety, the standard, and also to keep my design feature. So I think the difficult point is to find that balance. You have to negotiate each other and find the balance is always hard.
Yeah.
Yep.
I understand. Yeah, it's a collaborative process. So I'm curious, you all have full-time jobs, and what led you or what encouraged you to enter the Forge Prize?
Yes, I have the full-time job and I really love design. So I graduated the UPenn. I learned a lot of the the techniques from the school. So, but in practice, in real practice, we just design a really how to say that, normal design from my perspective. So I have the ambition to create some new language or new prototype on design. So I did a lot of competition or the research by myself. And as well, I'm running my personal studio. Only 2%, my wife and me. So we always do some research with new language. So, and make me excited. Yeah, that's my design life.
Yeah, in conventional practice, we don't get to explore or be as creative as these competitions. Yes, but yeah, how did you, either of you, Ho-gyum or Ahmed, how did you hear about it, or yeah, what encouraged you to submit for the Forge Prize?
Yeah, I was always aware of the Forge Prize itself, and yeah, I've been following it since its inception, I would say, and yeah, I've been tracking all the projects and this specifically, I mean, this project, because as a resident, I always felt the necessity or the lack of facilitating the rear yards itself. And again, that idea popped up, and of course, personally, I think the only way this project could be realized was utilizing steel. So that was the major, and I think it just came naturally that this competition or prize is more oriented towards pushing the limits of utilizing steel, and I think my proposal or idea was very aligned with it. So yeah, that's how I entered here. Yeah.
Oh, great to hear you've heard about it for a long time. Yeah. What about you, Ahmed?
For me, I teach in an academic setting, so I've always encouraged my students to submit to the steel competition, the student steel competition. And some of my students before won in the annual steel competition. So I was always looking at the Forge Prize and kind of think that when would be the good time to submit to it. My main motivation also is the exposure that the AISC has with the fabricator and the industry in general. And my hope and my goal is through that exposure that that this project can be can be scaled up and available in the market if when they see the benefits of it.
Yes, definitely. And I feel with all three of you going to be at NACC, the steel conference in Louisville, you would definitely get to meet and interact with all of the manufacturers in the steel industry, and maybe make some contacts to further advance your projects individually. Yeah. And I'm excited to find out who the one final winner is going to be presenting, right? So yeah, when we know the winner, I will probably tomorrow or so, we will let you know which date and what time, in which room the winner will be presenting their final product or the presentation. So I think it'll be a couple of more minutes. So I have a few more lighthearted questions. What inspired, this is like a question that every architect gets asked in some point of their life. what inspired you to be an architect? Like, where did your aha moment start?
It's been too long to recall those back in the day.
Sorry, your question is what inspire?
Yes, what inspired you to become an architect? Was it like a childhood dream, or did you decide in college, or when was the change or the spark?
I can start. I was inspired by my late father. He used to sell hardware tools, almost like a mini Home Depot or Lowe's. And I sit at his shop most of the time, surrounded by tools. So I had all of these tools around me, and of course I started to make things. And I didn't realize then that how fun is it to be able to use a tool and make something, and then perhaps also go and ask all the other artisans and shop, fabricators about how do you do this? So I think that was the beginning. When I come back from my school, so I walk back to his store, and then it was only 10 minutes walk, but I think it turned to be like a couple hours wandering around all of these shops and manufacturers, trying to learn from them how they do things. Most of them were steel fabricators, other were like, in the carpentry. So I think that was the origin.
What age were you at, if you don't mind me asking?
Elementary school.
Oh, wow.
So yeah, 10 years old. Yeah.
Yeah, that's pretty young. Okay, great. What about you both?
I have to recall, but frankly, I was also inspired by my late father, I would say, because he always insisted that, I mean, doctors were lame, architects are the real creators. You have the guts, and he didn't know. I didn't have talent, but as a father, he always insisted there was some talent. So which wasn't the case, but yeah, I fell into it, and and I think these works and projects are enabling me to be myself in a way, because yeah, it holds my voices, it nurtures my design sensibilities, and it kind of gives me a way to contribute to the bigger urban scale as a whole. So yeah, I think I don't know if it was a good answer, but that's mine. Yeah.
No, there's no right or wrong answer. It's it's your answer. What about you, Kaikang?
Because I had been painting when I was a little boy, and actually my mom, she's an accountant in a design firm, and that time she told me, be an architect is good for the make money, and actually my dad engineer. So yeah, I think influenced by my parents, I went to learn design. After that, I really love design, so I always do some design with my wife or by myself. Yeah, I think it's a good way to find myself now.
Yeah, that's great. Yeah, I'm an architect myself too, and similar to all of your experiences, my dad also exposed me to architecture. I didn't know it around maybe like 12 or something. I didn't know architecture or anything existed at that point. So yeah, our parents play a big role in being our inspiration. So I wanted to talk a little bit about the architecture center that AIC now currently has, and that I head. And during your practice or during your school, what resources or how did you get access to the steel resources? Where did you look for them? Just curious to know.
Google and of course, I mean, we had a big. I mean, it was one of the largest architecture libraries in the nation, so that was the main source, and of course,
Mm-hmm. Yeah, that's great.
but frankly, during the school days, we weren't that. I don't know. Myself wasn't. I wasn't that enlightened by the possibility of steel to dig into it that deeply, but yeah, since I've been practicing, and of course, steel is many times the main structural system of the superstructure in the buildings I design these days. So yeah.
Okay, thank you.
I'm now enlightened, yeah.
Yeah, looks like the jurors are back, so I'll stop asking you questions. You must be excited. You must be like, let's find out who's the winner. Or Jean will lead us. I'll give it back to you, Jean.
Hi, everyone. Well, I'm going to leave it up, hand it over to the jurors. I'll take it from here. They're ready to go.
Good. I'll start it off and I'll give you our quick roadmap. One, we've got 3 fantastic projects here, and we appreciate the investment that each of you have made. We're going to speak to the third prize, the second, and then the grand prize first. And I'll begin by talking about the third place entry. And Kaikang, this is one of my favorite projects since the very beginning of this submission. The geometry is exciting. It's very human in its consideration of scale and movement and inhabitation. And we found these, very commendable attributes of the project. We liked how steel can perform as both structure and cladding, and particularly appreciated the way that the structural logics have evolved since your initial submission. We think it's plausible, and ongoing kind of refinement and development of that, I think, would put this at an even higher level. And so, thank you for your contributions today. It's a beautiful piece.
Okay, well, that leaves me to discuss the runner-up, which this time is going to Ahmed Ali with the Transforming Sheet Metal Waste Streams project. And we really appreciated the story of the life cycle in repurposing steel from the auto industry. It's clever, it's plausible, and you've created well-researched and well-executed prototype that can scale. We're excited by the work that you've done and accomplished already, and really hopeful to see this go forward into the future, and maybe we'll encounter it in the city sometime before too long.
Great. So now I'd like to announce the winner, which is Growing Row Houses by Ho-gyum Kim. We think it's a robustly developed proposal with a timely architectural premise and a clear idea about how and why steel will be used to support the concept. It has a well-considered implementation strategy, including coordination with zoning and planning constraints, market demands, and erection efficiencies. It also fits neatly into new approaches to zoning within the Department of City Planning, specifically the larger City of Yes policies that are being rolled out. It also shows how structural steel is critical to unlocking buildable space in dense urban settings within New York and further afield.
Congratulations to all 3.
Thank you. Thank you so much.
Thank you.
Yes, congratulations, everyone.
Thank you, guys.
Really beautiful work. Thank you to all the finalists and entrants, the jurors, and the mentor fabricators for all your work for the Forge Prize competition. And we really love to see these innovative ideas using structural steel. So we will continually be in contact with all of you. But we're really happy to literally forge connections between architects and fabricators. So thank you again to everyone. Really, really beautiful work that we're going to be excited to feature.
Thank you. Thank you. Thank you. Thank you all.
Thank you
Keep in
Thank you very
touch.
much.